Hello guys, in a previous video you would have seen me take apart this kind of Chinese replica of a Siku tractor. It's entirely made of plastic, so it weighs nothing, and it's also 1/28 scale, so it's not even the same scale as the originals. Or actually it might be bigger than 1/28 scale, I'm not even sure. So the plan all along here was to replace the kind of rudimentary electronics that came in the model with our more customizable system, so that we can get a bit of speed control from the driving and control of the front loader here, and also the tipping on the trailer. So the right bit that we can get set up here. So to add control to this, what I'm going to use, instead of using the new version 4 controllers, I am going to use up some of the original prototypes that I had. So this is a whole box of prototypes that I've been working on over the years to, to kind of get us to this point, which is probably the most usable one. So I'm going to use some of these harder to control boards and just use them in this model to just to use them up really. Okay, so when I went to get the board ready here, I was soldering all this up, and then I kind of realised that these 1.27 connectors, the tractor actually came with 1.27 connectors. So I just soldered in a little bit of header. So all I need to do now is plug in the motor, something like that. And that's also going to work for the power supply as well, because it was coming in on the same 1.27mm header. So that's kind of worked out pretty perfectly for us. I've added a communication line to go to the trailer. So the trailer previously, just the motor driver drove the motor in the trailer up and down, pretty basic. But what I'm going to do is use the cable that came with the trailer as a power. So that'll bring power either from the trailer or from the tractor to the trailer. Probably from the trailer, probably put a bigger battery in the trailer. But then I'll just put another controller and or motor driver in the trailer. So when you hook it up with this line, you'll be able to send data back, and that'll mean that if we wanted to add lights or anything to the trailer, we'll be able to fully control them as well. Okay, so here we have our control board wired up to the two motors here, and the motor for the loader, and the final wire you see there is just the power supply. So it's using the original AAA battery power supply. So let's see, we should have control of the loader. There's the loader there. That seems to work fine. Then with our drive motors, left, so you're able to control the steering by slowing one motor down versus the other. We have a problem there. I seen the signal drop here, so the microcontroller was not responding. So it seems like when we try to drive both motors at once, it's cutting out. So let's have a look at the voltage, see is it dropping. It'd be strange if it was, because this board used to be able to drive these two motors using the three AAA batteries. But maybe, no, I presume it'd have to be able to supply the same amount of current. Maybe my batteries aren't fully charged. Okay, so hopefully we're able to see the voltage on the voltmeter if my camera is set up correctly. So let's see what happens. All I have here is the two wires hooked in. It just happens to be the wire I have, so I have a bunch of extra wires here, but we've no voltage. So I push in the battery. So there's 4.23 volts, which is kind of the same as a LiPo battery. So let's just see what happens. I'll try and put the motors going slowly. Already very substantial voltage drop there. So that cut out at 2.8 volts, and don't forget that that's 2.8 volts before the voltage regulator. So what the chip would be seeing is probably lower than that at that voltage, because the regulator, there'll be a little bit of loss in the regulator too. So that's what's happening. Maybe it's as simple as the batteries. I'll go and get different batteries just for the sake of it, but that also highlights a problem in my code. So if that's able to just cut out like that, I should put something in the code that stops it doing that before the voltage drops so low, because there's possibility there that the vehicle could go out of control. So I should have when the battery voltage drops to a certain voltage, that, you know, it maybe goes into limp mode, or maybe it just puts the hazard lights on or something like that and sits there until the voltage returns, or sits there for a certain amount of time. Because you could also drop the voltage by just trying to pull too big of a load. That would also probably be good for saving a gearbox, because if you were drawing so much current that you drop the voltage, then you're probably overstressing the gearbox, or going towards overstressing the gearbox. Well, I suppose it would depend on the type of motor and gearbox you had, but yeah, it's probably good just to have that bit of safety built into the code anyway, especially when it's so easy to do. Okay, so now we have 3 batteries that my battery tester at least is telling me they are fully charged. So let's see what happens then. .3 volts, a little bit higher than the last time, but that's with no load, so let's see what happens. Immediately dropping down again. That's not much good. It seems to be taking a lot of current just to get the motors to spin. So I'm wondering, is it actually the motors are kind of locked up or something. I have 3 nymph batteries here as well. They're charged, so I'll try them. Okay, so this is the 3 rechargeable batteries. Let's give them a go. They're only at 4 volts. No, same scenario. Something is obviously, well, I wonder, the other motor is causing a voltage drop as well, but the difference is there's only the one motor going, so it's not dropping so much that it's causing the chip to reset. I guess let's try this with a LiPo battery as well and just see what happens. Okay, so 4.2 volts on a LiPo should be fairly well charged. So it is pulling down the LiPo voltage alright, but obviously the LiPo is able to deliver the current a lot more efficiently. I guess it's a lower internal resistance. So you can do all 3 motors with LiPo without much difficulty. So it works with the LiPo but not with these original batteries. I'm not sure why that is. I know these batteries would have a higher internal resistance, but it was able to work when it was this controller, and I would have thought our motor driver is much more efficient. Maybe it's not. Maybe it's not as good as I think it is. Okay, so just to see what the difference is here, I've hooked up the old original board that came with it, and I've just added 2 wires here so that we can measure the voltage. So now we have 3.97 volts. Not sure if that means the batteries have discharged, or if this thing is just taking that extra bit of power to run, but anyway, let's see what way it goes with the motors. So no proportional control here, it's just on or off. And even with one motor, the voltage is dropping hugely. Let's just try the other set of batteries just to rule that out. So that was the rechargeable batteries. Okay, so a good bit more power from that, so maybe those batteries were just going flat. Still dropping the voltage a lot though. There's clearly more resistance on this motor than this one, because the voltage is dropping differently. When you try to run the two of them, you're getting the same kind of dropping out that we were seeing with the other board. This front motor seems to be way more efficient. Since we have the wire added, let's just see what would happen if we hooked it up to a LiPo. Not too surprisingly, when it's hooked up to the LiPo, it's working perfectly. So it looks like there's more to this problem than just that there's an issue with my board. So what I'll have to do is take a look at these motors and see if maybe they need to be greased or something to try and free them up a wee bit. But for the time being, I'm going to leave this video here. I'll try and come up with something to try and solve this issue. So if you liked that video, make sure and hit the thumbs up, and if you have any comments and suggestions, let me know below the video. But that's pretty much everything for today, so thanks very much for watching.